Okay, so this video will be about question 2. So for question 2, generally the format is they will ask you to find a particular constant in two approach, and then eventually they will ask you, hey, how come approach A give me the same constant, maybe 2.3, and then approach B give me the same constant, but this time the value is maybe 2.4. And they will ask you, do you think the two value kind of agree with each other, or like the two value doesn't agree with each other, so why? And basically when we set the question for question 2, we will put in some inappropriate instruction. Inappropriate in a sense of the equipment not good enough, or the method is basically a bit the method is a bit like doesn't make sense one. It has a lot of error in it. Yeah. So for example, I can even put like I want to boil water with a candle. Then I ask you, hey, how come the water never boil? Right. Then you have to say something like, well, the candle is not strong enough, or things like that. Yeah. So basically that is question 2 lah, is to check whether student, when they read the instruction, can they detect certain error or certain inappropriate steps inside the experiment, right? And this will give the marker a sense of your mastery in your practical skill lah, that you can detect like, hey, this instruction doesn't make sense, it's a bad instruction, right? So let's take a look at this. So when I approach question 2, the first thing is I always want to find out, okay, exactly what constant am I finding. And actually if you read through the thing, right, you will find that you go to the last step, right, you will find that they are asking you about density. So here you can see that the step A to C, right, step A to C will allow you to calculate density in one approach, and you get this. And then after that, the whatever step on top of K, right, will give you an expression that will enable you to find the density of the water, of the clay, right, density of clay, right. So both approach is trying to find the density of K, right, but you can see that the value is a bit off, right. It's very hard in real life that you got the reading exactly identical. There will be like some difference there, and they will ask you, hey, what do you think, which step do you think causes this, right? So if you look at this, you will see things like in the question, they will limit you to a certain weird process, like here they will limit you that you have to use the apparatus given to you. So even though, so when I set the question, right, I will plant something here that the apparatus will not allow you to do your job properly. So if you look at the apparatus, you have all these apparatus, one of it is the reason why the reading is off. So question 2 is set this way. You play around with the apparatus. Okay, so let's begin. So first, like I said, basic expectation. When you record reading, correct number of dp. When you do calculation, you know least SF or least dp. And then whether you can spot the error, that one really depend on your luck that day, whether you can see it or not. Okay, everybody have the same number of lab. So your experience versus student from other school is about the same one. You cannot squeeze too many lab inside, then you cannot finish syllabus, right? So most school will give you 4 or 5 practice and that's it, right? Is the number of days is like that only. Yeah, so let's take a look. Okay, don't make any error in your readings. Let's start. So first thing is your electronic balance. You are supposed to read from the reading as shown. If I remember correctly, our electronic balance can read up to 2 dp. And there are some that is 1 dp. I forgot. So this one you better check. If I'm correct, I think they accept both 1 or 2. So I will give you the benefit of the doubt. But like I said, go down to the lab and check. You see, some 2 dp. Okay. So in this case, I think it's 2 dp leh. Yeah lah, cannot be these 2 students is 2 dp, then this particular student 1 dp, right? So unfortunately, this one wrong lah. Okay, I think our electronic balance, it should be 2 dp one. It should be. Okay, but nonetheless, please read just record whatever that is shown on the reading panel. Okay, then after that, for part B, how do you measure the volume of clay? And clay irregular, you cannot calculate it, you cannot measure it. So correct, displace method. Fill the glass beaker with water, measure initial volume, then put it in, then after that check the final, subtract. Okay, good. Okay, and the best part is with the given operator, right, and the student got mentioned. What operator? Fill the beaker with place the thing into the water, get the new reading, then deduct the original water level, blah 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 blah. Okay, can. 1 mark. I would measure in the apparator, lower the piece of clay into the beaker and record the new volume, calculate the difference, blah blah blah. Okay, can. You see, we mark very linearly one for this one, for practical. Based on the process described, record the volume, then you're supposed to do it, right? To do it right, you are using beaker. Beaker, right, you cannot read until 0.01. It is not so precise. This one I remember. Now I remember already, I said this paper. The beaker is the trick. Why the reading is so off? Because the beaker cannot allow you to read the new water level properly one. So actually this one unfortunately wrong. It's actually 0 dp. Yeah, so this one should be 25. 0 dp. Yeah, unfortunately. Yeah. So this one, same thing. Wow, this one 1 dB, 1 dB become 2 dBA. This girl, I'm going to strangle you when I see you again. I know who you are. How can you do something like that? Simple subtraction is follow least dP. Not everything is SF, my friend. Okay? There are only 2 calculations is least dP. Simple subtraction, summation, or averaging. Okay, disappointed. This one disappointed because you never memorize and study. Okay, this is good. Wow, finally. Okay, for her, calculation a bit weak, but she is very diligent in following the formatting. You see the way she take down the notes, right? And you see just now in the design, right? She really write down what is being taught in lesson. So I'm pretty sure she got all the thing. Now the next step is whether she has the time to consolidate and really internalize this. Then she will get a good result. You see, she got good learning habit. It's just that her math is not so strong. Math not so strong, very easy to buck up and just do more. She will improve one day she will improve with her good learning habit, then the marks will come naturally. This one, even the math strong, without good learning habit, she is killing herself. So to cultivate good learning habit versus to improve in math, I feel that the learning habit takes time. Takes more time. Okay? This one, most ready among the 3. So far Okay, let's see. Then it's formatting again. So this one, all 1 dp, 1 dp, 1 dp, 1 dp, 1 dp. Very good. Then 1 dp, 1 dp, 1 dp, 1 dp, 1 dp, 1 dp. Working, very good. This one, 1 dp, 1 dp, 1 dp, 1 dp, 1 dp, 1 dp. Very good. No working, show working, okay? Okay, then place the thing, blah, 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 blah. Okay, let's do it. Okay, 1. Yeah. Oh, yo, 1. 1. Okay, then after that, doing the substitution. This one confirm list SF lah, right? 1. Okay. Or 2? How come this one 2 mark, this one 1 mark? Oh, this is 2 mark, okay. Okay, then 2. Okay. Then after that, you take, okay, unfortunately, this one is correct. So this one is correct, 3SF, 3SF, correct, 1. Right, this one is, how come, This one is mass over volume. Mass over volume impossible, wrong, right? It should be 5.03 over 25. Then this one should be 2SF. Wow, lucky by the way 0.20 is 2SF Okay, hey, this girl I'm going to strangle you soon. Okay, so like I said, you see even working is wrong, right? I will, as long as you you're lucky enough to give the correct answer, I will still give you the 1 mark one. Okay, so in your exam, in your practice, you see when you write the working like that, the teacher can correct all these things. Okay, so this error come from your earlier error of wrong DP. Then this one, I realized she cannot count the SF correctly. At least I will, of course you will feel bad about it, but at least you learn, you see. So write your working, then your teacher can correct you. Last one, this one should be 2 DP, correct. And so correct, 2SF, so correct. How come her one is 1 mark? Also is 1 mark Oh, okay, so 1 mark. Alright, last question. Why the two value could be different? When measuring the extension of the spring, we use a ruler. Cannot lah, ruler is not the problem. If you want to talk about the problem, right, the problem is when you use a ruler to measure your spring, you do not know where to park your ruler. That means our ruler, the 0 cm is here You do not know where is the start of the spring and where is the end of the spring. Very hard to determine. So if I were you, I would comment on when measuring the extension of the spring. So I will use back the same thing over here. When measuring the extension of the spring, the difficulty is not the precision of the ruler. The difficulty is it is hard to determine the center of the wire and align it to the 0 cm marking on the ruler, right? And you can repeat the same thing and mention that it is also hard to determine the center of the wire at the end of the spring and align it to the 0 marking, right? So it's not about the precision of the ruler. Okay, so unfortunately this one cannot give you lah. Okay, this one, the glass beaker, not measurement, the glass beaker's scale marking. Okay, what is scale marking? Your beaker, right? You got your beaker, then your beaker got this thing that tells you this is like 100 or this one like 0, right? This thing is called your scale marking. It's not accurate, unfortunately. It's not precise, right? Or you can say, if you don't want to use the word precise because it's too cheap, you can say that the scale marking are far apart. So for example, if you have a scale marking like this is let's say 100, then this is 50, then this is 0, right? Then so this is your beaker lah, right? Then you find that my water is like here, the yellow part. So what is my reading? Cannot read because the scale marking too far, right? So this will cause the volume obtained in C a bit off, and so it leads to the density in L to be inaccurate right? So unfortunately didn't really use the right word, so cannot give you lah. So this one they will be a bit strict. Measuring cylinder does not have enough precision to measure the volume of water. In which step? In step C. Step C or B lah, depending on step C or B. In B lah, okay? In C lah, in C. okay, which affect the density found in part L. Okay, this one I will condone that one tiny error and give. So I feel that the third person did a wonderful job. Okay, Ken? So this is the end of your Q2. The last video will be on Q3.